Hello, this is Chen Ming. We're back in the floodplain in River Murray in South Australia again. Today is 4th of February, and this is many times since we come back to this Jelly Bean Basin. Now, if you look at the landscape, it's been very different. So back in 2021, after the 5-year drought, this place was pretty much bare soil. So we watered it using environmental water, literally by pumping water to this area, and it was becoming a pond. And within the pond, there's a lot of aquatic vegetation, sneathweed to be exact. And once the water completely drained out by evapotranspiration and infiltration, it dried up, and then green vegetation started coming up. And later on, the floods come up to inundate the whole area. Inundated the whole area, and so it becomes aquatic vegetation dominated area as well. And then after how many years, this is roughly a year since the flood, the flooding water is completely drained out, and eventually this type of vegetation dominate this area. So I'm not sure about the name of the vegetation, but the height is pretty much up to the waist. It covers the whole floodplain. And interestingly, it's only this basin that the vegetation started changing as time goes. The rest of the higher floodplain, the vegetation coverage is relatively stable. So right now we are doing the ERT survey to be able to deploy this cable up to 128 meters. We basically cut the grasses and then pin down individual pins. And we are also doing the drone survey as well, so you can see all the cars is basically surrounded by the high grasses. I'm just keeping walking. Now, from this trip, what we find is that the groundwater level is about 1.5 meters below. And it was very high as compared to the groundwater level back in 2021. And 2021 is the end of 5-year drought. So at that time, groundwater table is about 6 meters below ground. And the reason why the groundwater level is still relatively high here is because the river water level, which is 400 meters away from here, is still very high. So the vegetation here basically uses the top fresh water coming out from the floods to survive. And you can see the leaves start to get green and then yellow, and eventually they all die out, and we will go back to square one. So here is the center of the ERT system. So we've got a computer and also 2 transacts. That's why we've got 2 sockets, and it's being powered by a 12-volt lead acid battery. And here we are doing the water survey at the moment. There was a weather station which was flooded back in 2023 floods. Just keep walking to the other side so you can see clearly we've made our way across it. So it's very interesting to see because this area now has got some denser vegetation as compared to the other places. So the other places are more like a bare soil. The vegetation takes a lot of soil water. So as a result, our moisture sensor tells the desaturation of the soil underneath is much quicker as compared to the bare soils. So because the basin has made itself as a water reservoir, particularly freshwater reservoir, and all different types of vegetation started to fight against them, against the other species. Yeah. And that's why different types of species dominate at different time point. So the survey will tell where is the phreatic surface, what's the salinity distribution, and in terms of salinity here, so even though this area, once being flooded, the pond will exist for roughly 10 months. But if you look at the underneath groundwater table, it is still very saline. And the reason why it's saline is because the only process that is able to dry up the clay is by evapotranspiration. And evapotranspiration does not take water away with salt left behind. So in that case, whatever fresh water comes in, they mix with the salt precipitated inside the clay and then become saline again. So that's basically the cycle across this particular site. That's the end of my quick update. Thank you.